Hello, everyone. Just kidding. Okay, so today what we're going to do is we're going to do both a little bit of, we're going to do arithmetic and a little bit of geometric. Okay, so, and then the second half of geometric we're going to do tomorrow. Normally I can squeeze them both into one day, but we have a little bit of time that I can separate them out for us. Okay, so arithmetic and geometric series. Okay. So, a series is just taking the sequence and adding it together. Okay? So, a series is just the sum of a sequence. All right? So, if I take this sequence over here, 6, 9, 12, 15, 18, that's a sequence. If I take those same numbers, but I add them together, that's the sum of the sequence. That's a series, okay? We're going to have both finite and infinite. Finite, of course, meaning it ends. There's a stopping point. Infinite being it goes on for forever, okay? Arithmetic series, we're only going to have the finite, right? And an arithmetic series is just a series of an arithmetic sequence, okay? Pretty straightforward there. Okay. So again, you don't need to write this down, but if you notice that we're going up by 1, still going up by 1 by adding 1, but we would add all those numbers together, okay? And this is when I used to do interactive notebooks. You don't need that. So this is our first formula. The sum of a finite arithmetic series, okay? So S sub n is our sum. N is still our term number, actually. Change that back to what we've been using. A sub 1 is still our first term. That hasn't changed. And A sub n is still our nth term. So if I'm asking you, find the sum of the first 7 terms, n is going to be 7. So then I am interested in the first term and the 7th term. And then I'm going to add those together, and I'll take 7 divided by 2, and I'll go from there. Okay. So over here, I just have the arithmetic sequence formula that we learned the other day. And now this formula. So for arithmetic sequences and series, those are your only 2 formulas you have to worry about. Kind of nice, okay? Let's try some examples. So my best suggestion for approaching these problems is to start out with what you know. I know a formula. I know where to start with that. I'm going to start with a formula. I know S sub n is equal to n over 2, my first term, and my nth term. Okay, so I'm going to start off with, what do I know? Well, they told me my first term is 16. They told me my fifth term is 28. And they're also telling me that it's S sub 5, which if this is n and it's 5, then so is this n. So it's just 5 divided by 2. Then it becomes, can you plug it in the calculator correctly, or if you can follow order of operations correctly. Go ahead and do that. Make sure you're keeping parentheses around what needs to have parentheses. Your calculator can only do so much. Okay, so what is the sum of the first 5 terms? Who's got it for me? Yeah?
110.
110. Okay, so on a test, you're freaking out. You forget the formula. Could you start with your first term and your fifth term? The information we learned the other day, we could count spaces, we could guess and check, we can do whatever, and then add them all together, and we found our series. Okay? Nothing is stopping you from using common sense. Okay? Does a formula make it easier? Absolutely. Less work. Okay? But if you don't know that during a test, then you can say, well, I'll just find the other 4 terms that are missing. 2, 3, 4, 3 terms. 3 terms missing in there, and then just add them together, and you're done. Okay? Let's go ahead and look at the next one. So if I start off with what I know S sub 7 equals, so if 7's down there where n's supposed to be, that's where it's going to go. I know my first term. What I don't know is my 7th term. Okay? So from there, there's 3 of them right there. I can continue the sequence and I can find the 7th term. Or I can use the formula we learned the other day. Okay? Either way, it doesn't matter. So if I want to know the 7th term, I know my first term is 8. 7 minus 1, and my common difference, it looks like I'm adding a negative 6. So again, all I have to do is plug that in the calculator and I'm done. Well, with that part of it. Okay? So if I take 6 times negative 6, I got negative 36, so I should get negative 28. And from there, I simply just plug that in, and I should get the sum of the first 7 terms as negative 70. but nothing is stopping you from finding all 7 terms by continuing the sequence and then just adding them together. Kind of nice how that works out. Why don't y'all go ahead and try the next 2? Not sure if y'all are aware in a TI calculator, to get the actual fraction button, you just do alpha y equals. I know some of y'all are like, well, I've been doing that for forever. Some of y'all said, I never knew that existed. So alpha y equals will make it a fraction. So then when you're plugging a lot of this stuff in, especially when we get to geometric, it'll make your life a whole lot easier too. Okay, so for the first one over here, if we have we're going to find the sum of the first 5 terms. So I have 5 divided by 2. I have my first term. What I seem to be missing is my 5th term. Now, some of y'all might have looked at it and said, well, I'm only missing 4 terms. I've got the first term, and I just need to get to the 5th term. And you're adding a half. So really, you could say, well, 2, 2.5, 3, 3.5, and 4. Add them together. Okay? Or you could have realized doing that whole process there, you found your 5th term. And then you could plug that in there. Or you could do both. Because you might realize, hey, that's 2 different ways I can check my answer. Okay? So if I do 2 plus 4, I get 6. divided by 2 gets me 3. 3 times 5 should get me 15. Okay. Or you could have used the formula from a couple days ago, plugged it in. So that's 3 different ways you can approach this problem. Any questions on those? Okay. Did anyone find a shortcut for the last one? Anyone realize what's going on the last one?
Define shortcut.
You don't have to use a formula. You did not find that way? That's okay. Did anyone find a way without using the formula? Okay. So if I really, 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 really wanted to, I could keep adding 3. That's not really a shortcut. Okay. What I could do is I could use the formula from the other day, find out what term number 116 is, and then go from there. I think my mind's thinking to the shortcut of the geometric one, so bear with me on that. So if I have S sub n, I don't know what n is. I know my first term, and I know my last term, but I don't know what term number 116 is. Okay? So from there, I can use the formula from, what was it, 2 days ago? So I have my first term, which is 14. Don't know what n is. Know my common difference is I'm going by 3. I also know what my term is, so I can plug in 116. So I can either start off by subtracting 14, divide by 3, add 1. Some people might have distributed, combined like terms, and then proceed from there. It doesn't matter. What did y'all get for your n value? How many terms are we looking at here?
35.
35, okay? So then all I would have to do is go in and get rid of this n here, and I'd put in 35. Like something like 1456 or something, is that right? Nope, 2275. Okay, so the good news is that you have 2 formulas to use. So if you start off with, okay, this is the formula that gets me the sum, but if I don't have everything that gets me the sum, I can then go to my other formula, and that will help me out with the rest. Okay? Any questions on those so far? All right. Try that one. A good old word problem that really you don't have to read too much of. So I like how this problem has you setting up basically what we've been doing. Because in order to find the sum, I have to know the last term. So they're asking you all of that stuff, but in the question. They're basically saying, hey, find the last, how many seats are in the last row, but then also find the sum. And And somewhere down, if you were counting everything out, you probably would have gotten distracted halfway through. So if I want to know how many are in the last row, I know there are 30 rows total, 10 seats in the first one, and then we add 3 after that. So if I start off my sequence and so on, to know the last row, I got to use the formula from the other day, which is a sub 30. What did y'all get when you found how many seats were in the 30th row? Someone tell me?
97.
97, good. So from there, it asks us, so that is an actual answer to one of the questions. Then it asks us, how many are there total? That means sum, okay? So the sum of the 30 rows, 30 divided by 2. My first term, which is 10. My 30th row, which is 97. How many seats are we dealing with here? Somebody new. $1,000 what? $600. That's not me questioning you. That's me thinking. I'm thinking of numbers coming together. Okay, 1,605. Yes, 1,605. Listen at me. You know what it is. That's what my mom used to always say to me. You know what I mean. All right, any questions on that? Like I said, if you find yourself counting out the seats in the auditorium, I guarantee halfway through, you would have already been distracted, okay? All right? Any questions on those? Okay. So let's look at a little bit of geometric. So geometric series is just a series of a geometric sequence, okay? So we're multiplying. The formula we were using the other day was the a sub n equals a sub 1 times r raised to the n minus 1. And today we're only going to talk about the finite series of a geometric sequence. And tomorrow we'll talk about the infinite, okay? Remember the difference between the two, finite meaning it ends and infinite meaning it goes on forever. Okay? Same thing, sequence, series. So here's our formula. We've got S sub n, still means the sum. We've got our first term. We have 1 minus our common ratio raised to the term number over 1 minus our common ratio. Same variables, same meanings, Nothing has changed. This is the one where using that function in your calculator here is going to come in handy, okay? Even through the mask, a yawn is contagious. Did you give it to me? Yeah. Jonah, did you give me the yawn?
No. You said yawn, I yawn.
Oh, really?
Yeah.
All right, let's go ahead and try the first one. Let's set up what we do know. Just like the other problems we've been doing, we're going to set up what we know. In 7 a.m., I actually started using the arithmetic series formula, and nobody told me to stop doing it. Until the end, I was like, this is not right. This does not make sense. And it took a couple minutes even after that for them to be like, you used the wrong formula. Tell me those things. In a kind way, though. So what we do know is our first term. We know that we're looking for 5 terms, but what we don't know is our common ratio. So we could count out spaces if we wanted to. We could use the formula from yesterday. It doesn't matter, okay? So let's say I want to know what my common ratio is by using this 5th term here. So 256 is equal to my first term, and then r raised to the 5 minus 1. Go ahead and figure out what our common ratio is. Like I said, y'all's formula bank, if you will, is very small, especially when it's separated between arithmetic and geometric. All right, so what is your common ratio? 2. If we divide by 16, the square root of 256 is 16. So if we divide by 16, and then if we take the 4th root of 16, or if we actually know what 2 to the 4th is, we would have that 16. So then I just simply plug my 2 in. And this is where it becomes handy for this feature here. So I'm going to go smaller here so I can see what's going on. So 16, 1 minus 2, or not, raised to the 5th power over 1 minus 2. And I should get 496. If you are using a calculator that either is older and doesn't have that feature, when you're plugging this in, make sure you're telling your calculator, this is my numerator by using parentheses, divided by this is my denominator. You have to actually group those together so it knows, okay, this is my numerator, this is my denominator. If not, it's going to follow order of operations, and it's just going to start doing things and not in the correct order. So make sure that you're doing that accurately. Okay? Any questions on that one? Okay? Go ahead and try these 3. See, earlier when I said, is there a shortcut to one? This is the one I was talking about. Bear with me. So what are we missing on the first example over here? What are we missing when we set up the equation? Do we have everything we need? I'm just asking. Do we have our first term? Do we have our common ratio? Could we figure out our common ratio though? Okay. Do we know the n value? So we're not missing anything. Okay. So these are the problems we really say thank you. And we move on from there because we only have to use one formula. So S sub 7, if we have our first term, which is 8, oops, not plus, 1 minus, now our common ratio, if we have issues going forward, we can always go backwards. So if I take negative 12 over 8, they're both divisible by 4, so negative 3 halves. Okay. Make sure negative 3 halves is in parentheses. In this particular case, since we're raising it to the 7th power, it's not going to be that big of a deal. But if it was raised to an even power, it would be a bigger deal. Okay, so make sure that you're paying attention to that. So if I plug in alpha y equals, do my 8 parentheses 1 minus negative 3 halves raised to the 7th power. There we go. All over 1 minus negative 3 halves. If you give me the decimal, great. If you want to give me the fraction, go to math, frac, and it changes it to a fraction. Fractions are just cleaner, but if you give me the decimal in this case, that's fine. So 57.875. Okay. The next one, we have our first term. We have what n equals, and we have our common ratio. Again, another situation. Thank you, and you move on. Okay. So if I have S sub 5, I have my first term. I have 1/2 raised to the 5th power, all over 1 minus 1/2. Then it just becomes, can you plug it into the calculator correctly? Nope, that's not what I wanted to do. Just wanted to move it over. So alpha y equals -2, 1 minus, and I'll just use 0.5, so I have to type less, raised to the 5th power, and 1 minus 0.5. So negative 3.875. Any questions about either one of those? Anyone get anything different? Need me to go through it with them? Is the calculator going okay? Is it because I said I was recording this, y'all went quiet? Okay. The last one. This is the one I was talking about originally about a shortcut. Anyone notice the shortcut here? Anybody? What's our common ratio? 3. So if I multiply 3 times 108, get 324, I think. Then if I take 324 and I multiply that by 3, that's all the terms I need. All I have to do is add them all together. I'm done. Okay? That would have kept you from using both formulas, figuring it out. Could you have figured out both formulas, the answer as well? 100%, okay? So this one ends up being $14.56. Does anyone need me to go through how to do it using both formulas? Did anyone do that and need assistance on that? I'll be happy to do it. Okay. Any questions on those? Oh, I keep going in my computer and it's throwing me over here. Oops. All right, so we have so far all of this information. What we are missing, we're not going to do the infinite series of an arithmetic, but we are going to do it of a geometric tomorrow, okay? So go ahead and get out your homework, and let's get started on that.